Hello, good day to everybody. Mingalaba from Myanmar. So we are Clitop Engineering from Myanmar. My name is Damien Track. And those of you who are watching our video for the first time, we are offering open lectures in mechanics. And we chose mechanics because one of the important foundations in engineering and science at the university level, and also, of course, for those of you who are sitting an international A-level test, this is important subject, and we want you to be able to teach mechanics subject watching our videos. And we have already covered a lot of topics like free falling, free throw upwards, the combined motion, and the projectile with some of the examples. So now let's look at the example problem. So if you read the problem, your particle is projected horizontally with a speed of u meter per second from a point 122.5 meter above the horizontal plane. The particle hits the plane at a point which is a horizontal distance of 90 meter from the starting point, and find the initial speed of the particle. So if you look at this problem, your particle is projected horizontally from a speed u meter per second. So it is projected horizontally, so this means initially the vertical component of the velocity in the one direction will be 0, and the initial speed in the x direction will be just equals to the capital U here, right? And your object initially is at a height of 122.5 meter above the horizontal plane. So if you sketch with the diagram, so you have the horizontal plane here, and coordinate origin is here, and your object is 122.5 meter above the ground, and then it is projected horizontally, so no initial velocity in the vertical direction, only initial velocity in the horizontal direction, which is just u meter per second. And of course your object will then free fall in the one direction, and then constant speed in the x direction, and you are asked to find the initial speed of the particle when the object so you are asked to find the initial speed, and you know when the object hit the ground, it is at the horizontal distance of 90 meter from the origin. So your object hit the ground at this point, and now looking from the origin, it is 90 meter away. So that is what is given in the problem, and you are asked to find the initial speed of the particle. So let's try to look at the approach for the solution to this problem. So you want to find initial velocity u, which is in the x direction, horizontally projected. And now if you look in x direction, the motion is constant speed motion, so this distance will be just s equals to u times t. And if you look at the initial velocity, which what you want to find, and the distance we know when it hits the ground is 90 meter, so you know the distance, but you don't know the time. So when you don't know the time, of course you're gonna find the initial speed, so you have to find the time. So from the x direction, you cannot get neither the initial speed nor the time, because you have two unknowns and only one equation. And now let's look at one direction. In the one direction, you know initial speed u, which is just 0, and the distance traveled in the one direction is just 122.5 meter, because originally it is at that height, and now when it hits the ground, it has already traveled 122.5 meter. So you know the distance s in the one direction is 122.5, and the initial speed is 0. Apart from that, you also know the acceleration of free fall, which is just 9.8 meter per second square. So if you look at in the one direction, you know the distance, you know the initial speed, and you know the acceleration, then you can find the time from the displacement equation, which is just s equals ut plus half at square. So you can get the time information from the one distance or displacement, and then you substitute the time in the x equation, and you will get the initial speed u. So that is the way we're trying to think about the approach for the solution. And of course, as usual, we will also think beyond what has been asked in the problem. So if you look at the we can also find the average velocity in the one direction, because initial velocity u is 0. The final velocity for the constant acceleration is just v is equal to u plus at. And after you find t, you can find the final velocity, and now of course you can find the average velocity in the one direction. All right, well. Now let's look at the solution. So I want to advise you to write the given parameter and then what you are asked to find, and of course the solution. So the given quantities are in a one direction. You know the distance y is just 122.5 meter. The initial speed is 0 because it's projected horizontally. In the x direction, you have the distance 90 meter, because when it hit the ground, it is 90 meter away from the origin. And initial speed u is unknown, which is just capital U meter per second. And you are asked to find initial speed u, and the solution, the approach, we have already thought about that. So we will start from the one direction to find the time. So we will take vertically downwards as a positive. So initial velocity in the one direction is 0, because again the particle is projected horizontally, and the distance in one direction is 122.5 meter, and the acceleration is just equals to the acceleration of free fall, which is just equals to g and 9.8 meter per second square. And please note here that g is taken positive because it is vertically downwards, and our sign convention vertically downward is taken as a positive. Now if you look at the distance in the one direction, y equals ut plus half at square, and y is 122.5, initial velocity u is 0, and you have half, and acceleration of free fall is 9.8, and t square. If you look at this equation, the only unknown is t. Then t square can be found by moving half and 9.8 to the right side. So half move to the left side, where we just multiply by 2, and the 9.8 will after it moves to the left side, you will just divide. So 122.5 times 2 divided by 9.8, you will get 25. So you will have t squared is equal to 25, and of course taking the square root of that, you will get the time t, which is just 5 seconds. And now you will substitute the time t in the x direction equation so that you will get initial speed of the object. So in the x direction, as a sign convention, we will take positive if the object moves to the right. So your initial velocity u is u meter per second, and the distance is 90 meter. And of course, since the motion in the x direction is steady speed, you have the distance equation, x is equal to just u times t, and x is 90 and t is 5, and of course u can be found by 90 divided by 5, which is just 18 meter per second. Right, so this is what has been asked in the problem. You are asked to find the initial speed. Now initial speed is 18 meter per second, and now of course as usual we're also trying to look at some other quantities which we can find based on the quantities that we know, even though they have not been asked in the problem. So let's have a look at that. So let's look at the extension which has not been asked in the problem. So if you look at the motion in one direction, because it's constant acceleration, the final velocity can be found by initial velocity plus acceleration time t, and then of course the v will be initial speed is 0 and the acceleration is 9.8, the time is 5 seconds, so you will get 49 meter per second. So when your particle hits the horizontal plane, its speed will be 49 meter per second. And now of course we can also find the average velocity v bar. Sorry, this should be v bar. So v bar will be just equal to u plus v by 2. So u is 0, v is 49 divided by 2, you will get 24.5 meter per second. So this is the average velocity of the whole journey in the vertical one direction. Right, so now let's try to make sense of the average velocity here. So in the vertical sense, as I had discussed in the previous video, if you have a 3-story building, normally the height is around 10 meter. So now this one we want to link to our average velocity. So your average velocity is 24.5 meter per second. So within 1 second, if your object is traveling at 24.5 meter per second. Within 1 second, your particle will have traveled 24.5 meter. So now that 24.5 meter, we want to show it in how many story. So 10 meter is 3 stories, so 24.5 meter will be just 7.35 story. And of course, the way you do it, just 24.5 divided by 10 multiplied by 3. So you will get around 7-story building within 1 second. So your object, within 1 second, it can pass through a height equivalent to 7-story building. So this is the way you try to sense of the speed. And of course, in this problem, the total time taken is 5 seconds. So in 5 seconds, your object, just multiply by 5, you will get around 36.75 story. So it's around 37 story. So it means that within 5 seconds, if your object is traveling at an average speed of 24.5 meters per second, within 5 seconds, it will have passed a height equivalent to 37-story building. So this is quite high, of course. 37 story is quite high, and it's falling around 37 story within 5 seconds is quite high in terms of the speed, right? So this is the way you're trying to make sense. And of course, if you want to prove, you can prove after 5 seconds you will get 37.5 story, and now 3 story 10 meter. If you convert to the height, you will get, of course, exactly 122.5 meter. So your object quite fast, and of course some of the object will be even lower, and you can have some even higher than that. So now you see, after you make sense of average speed or velocity, you in fact understand the problem more. But if you look at only the final speed, 49 meters per second, so that speed is only at the instant when the object hits the ground. But well, after you convert it to the average speed, this is just the average speed taken for the whole journey. So you can just link to the height 122.5 meter, and you will get the sense of how fast or how slow your object is moving, right? So, and I think with that we will just say goodbye. And of course, we want you to subscribe our channel, because we are going to cover all the problems in the textbook, in all the problem and exercise problems in the textbook. So please subscribe to our channel, and we will try to solve those problems, and of course learn further theory, and also link to practice. That is really important. So you don't have to work out only to get high marks in the exam, but you have to make the practical sense of those quantities that you have just calculated, so that you will get proper understanding, link it to the practice. And once you go into the industry, you are ready to apply those kind of practical skills. That is what we particularly aim in our open lectures. I hope you really see the benefits of learning with our videos. So stay tuned, and I wish to see you all in the next video. Bye bye.